Okay, so our integration rules for exponential functions, the integral of e to the x is e to the x. Well, the derivative of e to the x is what? E to the x?
Yep.
So it makes sense that that is. But your general rule is e to the u du is equal to e to the u plus c. Remember, du is u prime, right? So we're going to work on just remembering what we have to. So the big one we're going to remember is the second one because it works for everything. It seems really small. Is that really small?
No. It also looks very blurry. But it might be my eyes. I don't know.
Mine are always blurry. It does look really blurry, doesn't it? These PowerPoints are rather old. Maybe I should work on updating them. Okay, so find the integral of e to the 3x plus 1 equals dx, or not equals dx. E to the 3x plus 1 dx. So we need to find our u du. Yes?
Mm-hmm.
So what is u?
3x plus 1.
So 3x plus 1. And u prime or du?
3.
Would be 3 dx.
Yes.
Okay, so what are we missing? Aren't we missing the 3?
Yeah.
So how we miss the 3?
1/3.
1/3. So I have 1/3 the integral of e to the u du. So I just have 1/3 e to the 3x plus 1 plus c. Now the book puts that e to the 3x plus 1 all over 3. I do not like that. Takes up too many lines on my paper. You guys freak out when you see a fraction. You know. Okay. What's u?
Negative x squared.
Negative x squared.
Yep.
Okay. So u prime or du? Negative 2x dx. Okay, so I got the dx, I got the x. I don't have a negative 2, but I do have a 5.
Mm-hmm.
So what do I need to multiply by? I need to reduce the negative 2, but add in a 5.
So 5/2.
But negative?
Yep.
So negative 5/2. I'm adding in the 5 and reducing out the 2. The integral of e to the u du. So negative 5/2 e to the negative x/2 plus c. Now I would get upset if you didn't do this. Wouldn't I? Only because that's an easy one to move, right?
Yeah.
Now, if that was like negative x plus 1, I wouldn't make you do it. That keeps us honest and remembering that we're not supposed to have negative exponents, doesn't it? Are you good?
Yeah.
Okay.
Just wrote e. I mean x instead of an e.
Okay. Okay, so what's u on that one?
X squared. Or is it the one over x?
Well, okay, that's our choice. If we see a fraction, right? So if it's x squared is our u and du is our numerator, then we can use natural log, yes?
Yeah.
But is e going to be the derivative of x? No. So that's not going to work for us. But you saying, or is it this, is what I was talking about the other day. It's trial and error. We've gotten to the point that we have so many rules. If one doesn't work, you got to jump ship and go to the other one. You can't get hyper focused.
Well, because usually it's the bottom one, but then we talked about if the top one is bigger.
Mm-hmm. Right? The exponent. And when you got that e in there, probably you should take the exponent of the e. Okay, so we'll try that. So u equals x to negative 1. So that means du would be negative x to the negative 2, or negative 1 over x squared. And look at that. Is there our du?
Yeah.
Yep. So what do I need to multiply by? Oh,
Negative.
negative. So I have negative the integral of e to the u du. So negative e to the 1 over x plus c. So when we have an natural exponent, that, an e. I was trying to use a good math word and that wasn't coming to me. We probably are going to make our exponent our u, aren't we?
Yeah.
Okay. So next one, the integral of sine of x, e to the cosine of x, u is? So du is?
It's negative sine.
Good job. So we got everything but the what accounted for? The negative. So negative e to the u du. So negative e to the cosine of x plus c. It's not bad at all, is it?
No.
Yet.
We were just doing this. How do you
You know I gotta pull the evil laugh. Ainsley just told me I was evil. You good? What's this change? Anything?
It's adding in the one.
The definite, not the indefinite, right? So I just do it. So what's u?
Negative x.
And du.
Negative 1.
So what do I need to add in? Can I just jump to negative e to the negative x? Are you guys good on that?
Yeah.
Okay. Now I'm going to go from 1 to 0, right? So there's no plus c anymore, is there?
No.
So when I'm doing definite, remember I'm finding the area under that curve. That's what that means. So I have negative e to the negative 1 minus, plus, right?
Yeah.
E to the 0.
E to the 0 is 1.
Mm-hmm. So I have 1 minus 1 over e. I guess if you wanted to, you could e minus 1 over e. But without a calculator, that's what I got. With a calculator, I'd have whatever decimal that would give me, right?
Yeah.
I'm assuming everyone is good with putting that in a calculator. Okay. Ooh, this might be tricky. What do you think?
U is going to be the bottom one.
You want u to be your denominator? Is that what you said?
I don't know.
You said the bottom one.
Yeah.
Is that the denominator?
That's the denominator.
Is that what you said you wanted u to be?
That's what I'm saying it is.
Okay.
But I don't know.
Why are you acting like...
Well, I don't know which one it is, so I'm just guessing.
Why are you guessing the bottom? Why the denominator?
Because this is one
the
plus.
denominator usually the...
Yeah.
Usually, but it wasn't on the last slide.
Yeah, but I don't know.
The last slide, it wasn't a quantity in the denominator, was it?
No.
It was just a value. Okay? So we can.
Is it
We could be wrong too, right?
Or harder?
I don't know. It's been a year since I did this problem.
Oh, because when we do the derivative, the one's gone. So it's just the same.
So du is e to the x. So if the numerator, we've got u prime over u, so what rule is that?
I know. One of them?
Well, you.
Say your question again.
What integral rule is u prime over u?
That's the one we just did.
When?
I want to say
Few days
like
ago.
5.2. One of those.
Yeah, natural log.
Natural log.
Yes?
Yes.
Isn't it?
Yes.
If I got u prime, so I have the integral of 0 to 1 of u prime over u. That's what I have right now, right?
Yes.
So that means I have the natural log of u, or the absolute value, of 1 plus e to the x. Now, I have a question for you. Is that absolute value necessary on this one? Can e to the x ever be negative?
No.
Can't be, can it? So is the absolute value necessary on that one? No. But you'd have to put parentheses, right? Okay, so plug in 1, right? So the natural log of 1 plus e to the first minus the natural log of 1 plus e to the 0. So the natural log of 1 plus e minus what?
Natural log of 2.
Natural log of 2.
Can we leave it as that?
Hmm?
Can we leave the answer as that then?
Mm-hmm. We good with that?
Yep.
So can other rules sneak in there?
Yeah.
Sadly.
You guys got a lot more examples than the book does. Oh, never mind. Never mind. Not a lot more, just some more. Okay, what now?
Wouldn't it be the? Well, it would be e to the x, but wouldn't it be the cosine e to the x?
So what's our u?
E to the x.
E to the x. So u would be e to the x. And so du would be
E to the x.
e to the x dx.
Yeah, so it's natural log.
No.
I thought it was.
There's no fraction. I've got...
Well, now you're just confusing me.
Well,
Because I thought
What do we do?
if you put them u prime over u, that's natural log.
Yeah, but we don't have u.
Same.
No, there's no fraction there.
Oh, never mind. I see what it is.
I'm like, there is no Riley.
But wouldn't we have to divide by?
No, because we have, if this is our u, this is our du, we're good.
And they're
We
both
got the
there.
cosine.
I was just thinking if we had to take the cosine out.
Oh. I was like, what are you two doing? You're
Oh.
scaring me. Okay, what's the integral of cosine?
Yeah, you're saying.
Nope,
Oh.
it's not negative.
Sine.
Because the derivative of sine is positive cosine.
Yeah.
So I have sine. Can I just plug back in u now?
Yep.
E to the x from 0 to negative 1. So that would be sine of 1. Right?
Yeah.
When I plug in 0? Do I need to do that? Like actually show you that? Okay. Minus sine of e. Oh my gosh. The e came into sine, evidently. Oh, wait. E to the negative 1, not positive 1, is it? Now, without a calculator, that's it, right?
Yep.
Okay. Please use your calculator and make sure you're getting answers that you're supposed to. But, are we good? Okay, that's it.